All right, let's jump right in. For years, all the really powerful AI lived way out there, in these huge remote data centers. But right now, we are smack in the middle of a massive shift. All that intelligence is leaving the cloud and moving directly onto the devices we use every single day. Our phones, our laptops, you name it. And this isn't just some minor upgrade, it's a total rewrite of how we're going to interact with technology.
Just think about this for a second. What if your most powerful, most creative AI tools didn't care about your Wi-Fi signal? What if they just worked instantly, with absolutely zero lag, and all your personal data never, ever had to leave the safety of your own device? Well, that's not some far-off future. That's what's happening right now.
So let's unpack this first big idea. AI is packing its bags and leaving the cloud. The whole era of being chained to a remote server for every little smart feature is drawing to a close. And what's replacing it is something way more personal and a whole lot more powerful.
This slide really spells it out, doesn't it? With cloud AI, you're always at the mercy of your internet connection. You get that annoying delay, latency, and the big one, you have to send your data out to some server somewhere. On-device AI just flips the script entirely. It works offline, the response is instantaneous, and maybe the most important part, your data stays right where it belongs, with you, on your device.
So why the big change all of a sudden? Well, it's kind of a perfect storm of four key things coming together. First, privacy. It's a huge deal now. People and companies get the massive security win of processing sensitive data locally. Second, speed. You just can't have network lag for things like self-driving cars or even a snappy AI assistant. Third, money. It costs an absolute fortune to run those giant AI server farms. And finally, the technology itself just took a giant leap forward. We've got these new, super efficient models called small language models, or SLMs, that can run like a dream on a device with just 4 to 8 gigs of RAM. And this visualizes the new setup perfectly. You see, the old way involved this long round trip, from a data center through the cloud to your device and all the way back again. But now look at this edge AI model. The AI itself is deployed directly onto the devices. The processing happens right there at the source, which makes everything faster, more private, and way more efficient.
Okay, but how does this actually work? What's the secret sauce? Well, this whole revolution is being driven by a brand new kind of specialized hardware. So it's time to meet the engine powering this entire change, the NPU.
So what on earth is a neural processing unit, or NPU? To put it simply, it's a dedicated brain for AI, right on your device. It's not a generalist, like a CPU. Nope, it's a specialist. It's custom built for one job and one job only, running AI tasks, and doing it with mind-blowing speed while just sipping power instead of guzzling it.
I love this analogy because it makes so much sense. Think of your computer's processors like a team. You've got the CPU, that's the manager, handling all the general stuff. The GPU is the artist, a genius with graphics and handling tons of tasks at once. But the NPU, that's the new star player, the AI specialist. And just look at that last row. For AI tasks, it's not just a little bit better, it is 10 to 100 times more power efficient than the CPU. That is an absolute game changer for battery life.
So how do we even measure the power of these new AI brains? The new benchmark, the new yardstick, is a metric called TOPS. It stands for trillion operations per second. And the new magic number, the bar that Microsoft set for its Copilot Plus PCs, is 40. Any computer that wants to be called a true AI PC needs an NPU that can hit at least 40 trillion operations every second.
And you know what happens when a new standard like 40 TOPS gets set, right? It kicks off an absolutely incredible race. All the big chip makers are now in this huge battle to build the fastest, smartest, and most efficient NPU out there. So let's meet the contenders.
Here they are, the heavyweights. You've got AMD leading the pack in raw horsepower at 50 TOPS, which is awesome for multitasking. Intel is breathing down their neck at 48 TOPS, with a big focus on corporate security. Qualcomm's Snapdragon X hits a strong 45 TOPS and is, without a doubt, the king of battery life and efficiency. And then there's Apple. Its 38 TOPS neural engine might seem a little lower, but it's supercharged by this unique unified memory, making it an absolute dream for anyone doing creative work.
So, who's AMD for? Well, if you're the ultimate all-rounder, someone who codes, juggles a dozen open apps, and wants the absolute best bang for your buck, this is probably your chip.
Intel's Core Ultra? That's built for the business pro. If you're in a corporate Windows world where the IT department puts security and reliability above all else, this is the platform for you. It's designed to work hand in glove with tools like Microsoft Copilot Plus.
Qualcomm's Snapdragon X is for the true road warrior.
If your number one non-negotiable priority is battery life, I mean multi-day usage, and you need to stay productive anywhere without desperately hunting for Wi-Fi, its crazy efficiency and built-in 5G make it the obvious choice.
And of course, Apple Silicon. It continues to be the undisputed king for creatives. If your life revolves around apps like Final Cut Pro or Photoshop, or you build things for the Apple ecosystem, its incredible efficiency and flawless integration are just unmatched.
But here's the really crucial part. This isn't just about the chips. You can have the most powerful NPU in the world, but it's totally useless without a software ecosystem that can actually use it. So at the end of the day, hardware is only half the battle. This is a clash of ecosystems.
And what's wild is that each tech giant is playing this game completely differently. Apple is leading with this device-first, privacy-obsessed approach. Microsoft is leveraging its huge enterprise power with a cloud-first strategy, but it's quickly adding more on-device tricks. Google is making its Gemini Nano AI right into the core of the Android operating system. And Samsung is laser-focused on practical features that just make your smartphone more useful right out of the box.
Apple's strategy is especially interesting. See, when a task is just too complex for the chip in your hand, they don't just dump your data onto a generic cloud server. They use this thing called private cloud compute. It's a system built with their own chips that basically extends the privacy and security of your device into the cloud. It's a really smart hybrid model.
Okay. We've talked a lot about chips and tops and ecosystems, but what does all this tech talk actually mean for you? Let's get to the good stuff. The new AI superpowers that you're about to have. This is where it gets incredibly cool. Seriously, imagine you're on a video call and you're getting instant live translation in over 40 languages, all happening locally offline. Or think about intelligently editing a photo or getting a summary of a 100-page document in a split second. No waiting. And we are moving way beyond simple chatbots. We're talking about true AI agents that can understand a goal like plan a weekend trip to the beach and then actually go and execute all the steps to make it happen.
And the impact here goes way beyond just our personal gadgets. In medicine, this means super-sensitive patient data can be analyzed without ever leaving the hospital's secure network. On a factory floor, AI can predict when a machine is about to break, before it happens. In farming, drones can monitor crops in the middle of nowhere with no internet. And in cars, that zero-latency response, that isn't just a nice feature, it's what makes safe autonomous driving even possible. And believe it or not, this is really just the beginning. If we look just a little further down the road, the next frontier is something called neuromorphic computing. We're talking about chips that are literally designed to work like the human brain. They promise a future with even more powerful and even more efficient intelligence right in our hands.
So, as all of this incredible power moves from some distant, abstract cloud directly into our hands, the debate is pretty much over. Our devices are smart. The real question, the one we all have to start thinking about now, is what are we going to do with all this new intelligence? How are we going to use it to create, to connect, and to solve real problems? The tools are here, the rest is up to us.